All right, we're going to continue our discussion in section 10.2, talking about displays of data. I believe we had left off on having just talked about a grouped frequency table, which looked like that. Is that our last one? Excellent. So we're going to actually extend this idea to create something called a histogram. So a histogram is made up of adjoining rectangles or bars. The categories are shown along the horizontal axis, and the frequency is shown along the vertical axis. And we're going to use the same set of data that we just used for our grouped frequency. So we're going to use that grouped frequency table to construct a histogram showing the numerical disbursement for the data. So the pieces that are important are the frequency and the grades. I'm going to copy it, just shrink it up over here so that we have it as a reference point. So this was our frequency table. My tally T did not show through. And these are the numbers that are going to be important for our table. So we're going to draw a horizontal and a vertical axis. The vertical axis is the frequency, and it should be labeled. Anytime you have axes, they need to be labeled. And then you can see the frequencies that I highlighted go from 2 to 9. So we need to have our frequency axis going up to 9. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And you don't necessarily have to label all of the values, but maybe like every other value, every third value, something just so that you can see them easier. So I'm going to label the evens, 2, 4, 6, and 8, just as a reference point. And then my horizontal axis is going to be the grades column. So I'm going to start at 60. And I'm going to go over here. And it's not actually going to go to 69. I'm going to do the beginning of the next column, which is 70. And then 80. 90. And 100. I'm going to shift my graph over just a little bit. I'm running off the board. Okay. And then we need to label the bottom axis as well. We label the left axis, the vertical axis frequency. This axis down here are the grades. And I have a great tool that lets me make bars. So I'm going to make bars. I'm going to make a bar of height 3 for the 60 to 70 category. So it represents that 3 people made grades between 60s and 70s. And then the next one should be 2 people. They're the grades from 70 to 80. And then I have it's a little bit better. I have 4 in the next category. And the last one is supposed to be 9. So a couple of things about these graphs is that your bars should be about the same width. It's misleading if you're doing them so that they're different widths. Your spacing should be right on the bottom, right, 60 to 70 to 89. Those class widths need to be uniform, or otherwise it doesn't make sense either. So there's a lot of kind of visual detail kind of things that we want to make sure make reasonable sense. And then we need a title for the graph. And the title for the graph is much like the titles we've been working with before. These are grades from a second exam. Okay, so one of the important features about a histogram that's going to change in just a moment is that the rectangles are adjoining, right? They're touching one another, okay? So typically histogram kind of data is data where there's a continuum of values. So if you were really looking at grades, it kind of makes sense that it would be a histogram because there's no space really in between the grades. Does that make sense? It's on a continuum of values. Now, if you think about a bar graph is much the same way. I don't know why there's 2 of those. But there's actually spaces between the bars instead. So these spaces are actually what makes the difference here. So having the spaces between the bars is happening because we're either interpreting or because the data necessarily is categorical data. So imagine if you were doing this and you were trying to show the difference between male and female. There's not a continuum. Contrary to popular belief, there's not a continuum. All right? So it makes sense that the bars don't adjoin. With this, we actually have data values that could be viewed as categories instead of as a continuum. In particular, the way that they could be viewed as categories is because we're thinking of them in terms of the letter grade that they represent instead of the numerical value of that letter grade. Right? So instead of those like this, the numbers here, we're actually talking about values that were, was the 60s first? They were, right? D, C, B, and A. So we're thinking about categorizing it by a letter grade instead of a numerical value. Okay? So as we think about this, even though we're using the same data, we are thinking about it from a different perspective. Another example of something where categories would come into play, and this happened, I actually edited the yearbook when I was in high school, and we did a lot of charts and tables and things, and we'd ask questions, and we'd categorize our data based on their classification. So freshmen said this, sophomores said this. It's not a continuum. You're either a freshman or a sophomore, right? So those were categories that we did. And you can categorize lots of things. Some are more natural, definite kind of categories like that, and some are more arbitrary, like the one we're working with here. So this works the same way. All my bars are the same height. My vertical axis, my horizontal axis, it's all the same. Okay, everything's the same. I just have space between my bars. Literally the only difference, okay, in terms of the visual for it. So as we're drawing it, we have our frequency here. We're going to label it the same way. We're going to make our hash marks, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm going to label every other one just because too much labeling can sometimes be distracting as well. And then along our bottom axis, it's actually the letter grade. And so as I make this mark, I don't label 60 and 70. I label this sort of in the center of it as the D's. Okay? And then as I make my next hash marks for my next bar, these are the C's. And then I have the B's. And then I have the A's. And on this one, you might actually see it flipped around where the A's are listed first, and the B's second, the C's, and then the D's. That's a possibility as well of how to see this a little bit differently. But these are the letter grades. If you just said grades, that'd be okay as well, but specifically we're looking at the letter grades this time. And we're drawing our bars based on the same data we did before. So the first one was 3. And then there's a gap, and I have a bar of height 2. And a gap, and I have a bar of height 4. And then a bar of height 9. Okay, I'll be able to see more of my screen. I think I got them all. There's gaps between. The bars should look about the same width apart. And we can label this as grades on a second exam. Any questions? Okay, do you remember when we did the back-to-back stem and leaf plot last time so that we could make a comparison? Well, the next set of description is actually much like that. This is called a double bar graph, and it's also used to make comparisons in data. So as it's used to make comparisons in data, what we're going to have is we're going to have some bars representing one type of data juxtaposed right next to other bars representing a different type of data. So we're going to use our back-to-back stem and leaf plot so that you can see how you would create that kind of a graph. So I'm going to actually do the same thing I just did in the previous one with the group frequency table and just copy-paste. You can just flip back and forth as you're looking for your values. But if I flip back and forth too many times on my screen, we're probably all going to get seasick. So this was my back-to-back stem and leaf plot. make it small-ish up there. And we're going to create a bar graph like we did before. And in our bar graph, I need to know the same category kind of information I did before. So I'm going to do letter grades though, okay? So although my bar widths are going to be the same distance, the numerical values are being compacted into a graded number. So for example, 90s, how many of them are there here? 3? Is there still 9 of this one? That's the 9 one. 4, 2, and 3. So those are the data that we had from our grouped frequency values. But over here, there's 4 A's, 6 B's, 4 C's, 4 C's, 1 D, and then all of this are the F's, even though they span more than 10 points. That's what I was trying to get at. So there's actually 3 F's on here. Okay, so as I create my bars, I need a bar representing the different letter grades, but now I need to include the letter grade F. I'm going to flip it around just to show you that it doesn't matter if you do A to F or F to A. So I'll start with my A's on this one. So I'm going to make a wide bar that's representing A, and then I'm going to leave a space, and then the same distance wide-ish bar representing B's, and a little distance. I have my C's, my D's, and my F's. And I'm going to split each of these in half, and I'm going to change the color just so that you can see it a little bit better. And I probably don't have my, because I keep zooming in and zooming out, I probably don't have my widths quite as even this time because it's so much wider. But that's split about in half of each of them. And so we're going to put the first exam in front of the second exam. So on the first exam, we had 4 A's. On the second exam, we had 9 A's. So I need a frequency that matches that. So my biggest value is still, again, 9. So my frequency will look much like it did before, 3, 4. And it's going to say frequencies or frequency. And down here it's going to say grades. I don't really have space at the very bottom, so I'll put it out to the side a little bit. And I want to make a bar, but I want to make my bar the right height. Now, what I'm going to do is I'm going to make my bars different colors. So I would suggest, as you're working, to use your pencil to make the bar. But then in a moment, if you have a color, you can use it, or you can shade it using like certain hash marking or whatever to differentiate. So let me show you with my colors what I mean on the first couple, and then I'll show you what to do if you don't have any other pen. You know what? I think I have some markers, actually. Does anybody need a marker to have some color? Okay. So if you need something colorful, grab something colorful from somewhere or somebody. So I'm going to make my bars, I'll do red and blue. So the first one, these are letter grades of A. I should label them actually. So here's A, B, C, D, and F. So the letter grade of A, there were 4 A's. And then we have the letter grade of A on the second exam, and it had 9 A's. So I'm going to switch to blue, and I'm going to draw it with a height of 9. Okay, so you can draw your square or rectangle bars, and you can shade them in. And then we're going to go on and do the next one the same way. So B's, how many B's were on the first exam? 6. So I'm going to draw a bar of height 6. And then B's on the second exam were 4. So we're going to do a bar of height 4. And then on the first exam C's, I had 4, and the second one was 2. So this is a 4. And then 2. And then my D's on my first exam were 1. And on the second exam is 3. So 1 first. And then 3. And then there were no F's on there were 3 F's on the first exam and no F's on the second exam. So I'll end with the 3 F's on the first exam, and then I'm done. With the bars anyway. There we go. So here's my bar chart. The only gaps that I should be seeing, if I've drawn it well, are the gaps between the letter grades, not between the individual blue and red bars. I do need a key that specifies what the red and the blue bars mean. So I used red to represent one of my exams, and I used the blue to represent the other exam. So the red are the exam 1 grades, and the blue were exam 2 grades. So some kind of key depending on what you used. And these are the first and second exams, or the first and second exam comparison, something like that. Okay, does that make sense? All right, now we're going to use our protractor. So you ready? Okay, our last one in section 10.1 that we're going to look at is a circle graph or a pie chart. They use the names interchangeably. This consists of a circular region partitioned into disjoint segments. You've all seen pie charts before. The graph actually shows how the parts are related to the whole. So this kind of a graph, or even the other graphs like these, what they're doing is they're comparing something to one another. We're comparing the pieces to one another. But in a pie chart or a circle graph, we're actually comparing the pieces not to one another, but to the whole, the whole pie. So it's a little bit different of a purpose behind it. It's kind of like the difference between odds and probability, right? Odds is a part-to-part comparison, just like my bar graphs are. And then, the probability was a part-to-whole comparison. That's what a circle graph does for us. It gives us a part-to-whole comparison. So we're going to use the same group frequency table in example 5 to construct a circle graph for the letter grade disbursement from exam 2. So let me get this group frequency table one more time. And what I need for you to do is to create a circle. So if you have something that you can trace around the edge of to make a circle, that'd be great. Borrow a can or bottle from somebody. You guys are welcome to try this bottle. If you stay on the edges, it'll work okay. So if somebody wants to use it. Y'all ate my cupcakes, you don't have to be scared of my germs. It's not going to work anymore. Okay. And so you're going to draw a circle, and I have a circle tool, so I'm going to do the same-ish here. So you just need to circle somewhere on there. We're going to need to do a bit of data, like counting or calculation before we can actually use the circle. But you're going to need a circle, and you're going to need to mark what is approximately the center of your circle to make any of this work. Okay? So now what we're going to do is we're going to go over here to this circle graph, or not circle graph, but group frequency table. And I'm going to delete out the center the table because what I need is I need to be able to write some other pieces on there. Thank you. Okay, so I'm going to move my frequency over here. I've done some erasing, so everything's looking funky. What I need to know is I need to know how many exams there were. That's the first thing I need to know. Like, it's a part-to-whole comparison. Well, what's the whole? So add the values together. How many people's values do we have exam scores for here? It's 18. And what we want to know is we want to know how much of the whole is each of those values. So what we're going to do is we're going to find the percentage, and along with that, in a separate column, we're going to find the degree measure. We'll say measure. So the percentage is found just like you would find a percentage on a test grade. You take the part, you divide it by the whole, and then you multiply by 100%. Okay, so I'm going to need some more space. Let me shift this over a little bit. All right, that's good enough. All right, so you're going to need your calculator. Go ahead and grab it. On all of these, we're going to round to the nearest whole percentage. Okay, I'm not working on decimals of percentages here. So we have 3 over 18, and then we've got it multiplied by 100. And what percent does that give you for our D's? Yeah, if I round to the nearest percent, we're at 17%. Now, before you move out of that direction in your calculator, if you also take the 3 over the 18, okay, which was the 0.16 repeating, and you multiply it by 360 instead, so the same 3 over 18, but instead of multiplying by 100, we multiply it by the degrees in a circle because that's our whole for 360. This gives us a 60-degree angle for the first one. Okay? We're going to do this for every single value listed. So I have 2 over 18 now times 100. And I have 2 over 18 times 360. So 2 over 18 times 100 is 11%. And if you multiply it by 360 instead, you have 40 degrees. We have 4 over 18 times 100. If 2 over 18 is 11, 4 over 18 must be 22. And 4 over 18 times 360. If it was 40 before, it has to be 80. The last one's 9 over 18. Hopefully you know that one just by looking at it. It's actually 50%. And if you do 9 over 18 times your 360, you get 180 degrees. Now, you don't have to show me all the calculation pieces. Like, do you really have to write down 3 divided by 18 times 100 for me? For 3 divided by 18 times 360? No. But I should at least have record of your work showing these values and these values. Like, that's the information that's going to show up and be used as we make our graph. Okay? So we need those pieces. In particular, the ones we need to actually make the graph are the degrees. We'll show you what we're going to do with the percentages in a moment. So let me remind you how we use a protractor. I wish I had like a big giant one that I could show you on the screen. So what I'm going to do instead is I'm going to sort of sketch the protractor itself on here and then erase it so that I can show you what I'm going to actually do. So what we're going to be doing is you're going to be lining up the center of your bottom of your protractor, however it looks. There's like a dot in the middle and it has a vertical and a horizontal line through it. Do you see that on your protractor? Something like that? Okay, that dot has to line up on the center of the circle, generally speaking, as we're working. Now, the first thing we need to do before we start lining anything up is that we need to draw a radius somewhere. It doesn't have to be drawn the direction I drew mine. It doesn't make a difference at all if it is. But you need to draw the radius from the center out to the edge of the circle. After you do that, you're going to take your protractor. That dot that's in the middle is going to be on the dot of the center of the circle. And either either side of the horizontal line, depending on which way you're measuring from, needs to line up on top of the line. So it should look like, this isn't big, but it should look like this. The dot's lining up in the middle here, and then this line is lining up on my radius. Okay, is everybody good with that? Now if you look along the edge of the protractor, you see numbers that are both increasing and decreasing. One of them says 0, 10, 20, 30. The other one says 180, 170, 160, 150, right? Well, we're measuring from the smaller angle out. We're going to use that first one, which is the 60-degree one, and we're wanting to measure so that the numbers as they go outward reach 60 degrees. That's our goal. So as we line this up, you can't see me line mine up exactly right here, but I'll be doing it just like you are. I need a smaller one. So if we line this up here, and you mark sort of out in the space, if it doesn't actually show up on the edge of the circle, where the 60 is. What you're then going to do is you're going to line up your ruler so that it connects the center of the circle to where that mark is. You don't necessarily have to proceed out of the circle, but it would stop right there. And this would be the 60 degrees that you just measured. This is the D range. And the letter grade and the percentage go in this category. So this is D, 17%. You do not need to write the degree measure because the degree measure is inherent in what you did because the size is the degree. Okay? So I don't care whether we proceed sort of to the clockwise or counterclockwise from the D. It doesn't matter. I tend to go counterclockwise. I don't know necessarily why I do that. But we need our values to go in order. So D connects to C. We're going to do C next. I'm not going to jump to B, right? That's not what we're doing. We need to go in order. It doesn't make sense if we don't. So we're going to go to the C range next. The C range is going to be that 40-degree mark. So you're going to line your protractor up, again, with the dot in the center. But now instead of it being down here, it's going to be up here. So the dot's in the center, and your lined edge that goes through the center, and your protractor will line up with the new radius that you just created when you ended the segment with D in it. So it's supposed to be 40 degrees. It's about right there on mine. And then you're going to line up your ruler, or the edge of the protractor if you wish, between the dot in the center and the mark that you've made on the outside. So it goes to somewhere about right there on mine. This one is the C range, and it's 11%. So at the points when I've used a circle graph, which sometimes I do and sometimes I don't on this test, I do measure this. Within a little bit of accuracy issues is fine, but if we're significantly off, then we have to rework problems. So you do want to make sure that you understand how the protractor is working for you. So we did D, we did C. Now we're going to do B, going the same direction along the circle. So the B has to go beside the C. This one is an 80-degree mark. Now, we can do that, and that's fine. But do you notice what the A angle should be? 180. 180 is amazing, because 180 is half a circle. So instead of doing it and measuring out the 80, which would be totally fine, and we could do that, I'm going to measure the other direction from D. So if I take this one and extend it, right, then the B's are going to be here, and here's my A. And this is most definitely 180 degrees. Right, it's half of a circle. So this is my 50%, and then this would be, by default, be my 22%. And you can check to make sure that that measures up. Now, I don't usually talk about that, but we've drawn it this way, so I might as well. If I've done this at this point and I want to make sure that the angle B actually measures correctly, I could actually line up the dot on the center with either of the two angle pieces marking the side for B and the line. And I could make sure as I'm looking as it goes straight out that it goes through 80 or pretty close as I'm working with it. Okay, 80 or pretty close. There's one more thing that this graph needs. A title. It does. And you're probably sick of this title by now, but this is the grades on a second exam. All right, any questions about the protractor? All right.